Hi everyone, I wanted to make you a quick video to talk through some of the homework problems for your assignment this weekend. Alright, some of the problems ask you to solve either graphically or numerically. I think that it's number 2 on the mathematical skills problems. So here's a sample problem. If you wanted to solve a quadratic equation like this one, if you wanted to solve this numerically, basically you're just trying to choose x's and take a guess at some x's that would make the equation true. So this would not be my first choice. I'd rather solve this one graphically if those are the only two options. Of course, the theoretical is nice if you remember the quadratic formula, but if that's not an option in number 2, then I would like to do this graphically. But if you wanted to do it numerically, okay, so for example, let's say you guess x equals 1 is a solution. Alright, so then you would just plug in 1 for x, work out both sides of the equation, and see if this is even anywhere close. So, 1 is not a solution. And then from there you would just guess different x's. This is trickier. It's not like some of the linear ones we've done where you can clearly see a pattern that, like increasing the x, by, like maybe 1 here, or decreasing by 1 or something, where you would see kind of that same up and down pattern in the equation. So in here we're also looking at solutions that may be irrational or decimals or fractions or things like that. So instead, let's look at how you would do this graphically. I've used Desmos to do this, and the gist is that you want to treat each side of the equation as its own equation. Alright, so I'm going to look at this expression and this expression, and I'm going to set them both equal to y. Okay. Now I can do that because I've really kind of just inserted this y in the middle of a little chain here. So if I have 3x squared minus 6 equal to y, and then I also know that y is equal to 5x minus 6, well then I know that 3x squared minus, oops, sorry, that's a 3. Okay, so if I have 3x squared minus 6 equal to y, and y is equal to 5x minus 3, well then I know that those two expressions are equal. So I haven't changed the equation at all. I've just broken it up into two different pieces. So now, to look for a solution to this blue equation is the same thing as looking for a place on the graph where this y value is equal. Because that's what we were assuming when we set these equal to each other. We're assuming that this y and this y are the same value. That's the only way we can put those equal signs in there. Okay, so here are the two equations, and I've entered them in separately but plotted them on the same axes. And then this Desmos calculator is nice because it shows up with points that you can just click on, the intersection points of the two graphs, the red and the blue there. Okay, so we've got our red, the expression that was linear, the line, and then the parabolic, the quadratic one. Alright, and then you would just look for the x values, because remember we're trying to solve for x, not for y. And so here we actually have two solutions. Okay, and these are approximate ones. They're rounded to 3 decimal places, but they're negative 0.468 and positive 2.135. Now if you wanted to check those, you would just go back to your original equation and you would substitute those values in for the x one at a time. So let's say I choose 2.135. 2.135. Okay, substitute that in on both sides. And when you work this out, you should get both sides of the equation approximately equal to each other. It won't be perfect since that's a rounded solution, but it should be pretty close. Alright, so that's using Desmos. The same idea applies if you're using a graphing calculator. You would just go to the graphing function, alright, and where you have y equals, you would enter in these two different equations and graph them. And then if I'm not sure about the Casio calculators, but I know the TIs, you can trace each graph. You can use your up and down arrows to jump between the parabola and the line, and then you can use the left and right arrows to sort of move along the curves. There's also a feature like find the intersection points. Okay, and the gist, you just have to place your cursor. So you're going to have like a little blinking cursor. So you're going to go into the find the intersection point, and it's in one of the function keys along the top when you're in the graph. And you'll click that, and then you'll have a cursor, and you just need to set it like kind of to the left of your intersection point, like maybe here, and then maybe along on the other side, something like that. And then it should calculate and tell you, again, an approximation for that point. Some of the other questions ask you to factor. I'm assuming that this is something you're at least familiar with as a course prerequisite, but just in case not, let me give you a quick review of one way to factor, and then I would like to talk about some different approaches the next time we meet in person, some that are, I think, a little more interesting and faster. But one way you can do this, all right, this is a quadratic equation. Make sure it's set equal to 0, and then to factor this, okay, all of these quadratics, if they do factor, they're going to factor as two binomials, two things with two terms. Okay, and then 6x squared, we're looking for two factors that multiply to be 6x squared that are going to go into the first two spots, the first term in each of these parentheses. So you have two options here, and we're not looking for fractions or square roots or anything, we're just looking for integer factors. So this could either be a 3x and a 2x, or a 6x and a 1x. So this method, you're just kind of using guesswork. So maybe I'll try 2x and 3x, and maybe we'll get lucky. And then in the last two spots, you want to take this -5 and find factors of -5 to go here and here. All right, so we're looking for one positive, one negative, and we really only have one choice here. It's got to be well, it's 5 and 1, but it could be -5, +1, or vice versa. So let's try it this way first. And then you may remember that you may need to play around with the plus or minus sign, or you may need to switch the position of the 5 and the 1. And what you're looking for is something so that these middle terms and these outer terms, their products are going to add up to this -7x in the middle. So right now I have -15x and then +2x, so that's going to be -13x, and that's not -7x. If the number's correct but the sign is wrong, like if this had added up to be +7x, then I would just switch the plus and minus signs. But since it's the wrong numbers, then next thing I want to do is try switching the 5 and the 1. We'll see if that helps. Okay, so now we have a -3x and a +10x. And so now we have 7x, so it's the right numbers, just not the right sign. So I'm going to flip-flop the plus and minus signs. Plus and minus. So now we have +3x minus 10x is -7x. So that's the correct factorization. If none of those had worked, then I would go back to the 2 and the 3x, and I would try 6x and 1x. Okay, that's a fast summary of factoring. You can find a lot more information online about that, or ask if you need some extra help. And your textbook gives a brief summary, but doesn't go into a lot more detail on how factoring is done. Then from there, for solving, your textbook talks a lot about just observing the solutions from here. They mention that there's something special about putting 0 on this side, and you may remember that there's something called the zero product property. And basically this just says if we have two numbers, so I'll call them like number 1 and number 2, and if you multiply them and the answer is 0, then that tells us that one of these two numbers has to be a 0. So you can't have things like, 5 times 3, that's never going to be 0, or square root 2 times pi, that's never going to be 0. The only way to get 0 as an answer is for one or both of these numbers to be a 0. So we have sort of the same thing going on with this equation. We're just going to think of those two parentheses as the two numbers. So when I have those two factors, okay, the 2x plus 1 times 3x minus 5 equal to 0, I'm thinking of those as n1 and n2. And so then I know that either 2x plus 1 has to be a 0, or the other factor, the 3x minus 5, has to be a 0. Okay? And then from there you can solve those equations and get your two solutions. So negative 1/2 and positive 5/3. All right, and then you can confirm, plug those back into the equation, and check and make sure that it does equal 0. The other thing I wanted to mention, your textbook talks about descending order, and they ask you to write polynomials in that form. And they do talk about standard form, but I don't know if they ever actually said in like a big, a property box or a definition what they're expecting for standard form. So let me remind you of that. For a quadratic equation with just an x as the variable, we're looking for something that's ax squared plus bx plus c equals 0. That's standard form. Okay. Now that they did talk about other quadratic equations, things that maybe have like an x times a y, and then the standard form looks a little bit different, but we're mostly going to be working with quadratic equations with just one variable like this. All right, so for example, 3x squared plus 2x minus 7 equals 0, that's standard form. Even if one of these terms is missing, like maybe it's just 5x squared minus 6 equals 0, that's still standard form. Okay, we just have a middle term equal to 0. But what you want to avoid is having things kind of rearranged, like if we had maybe a 2x out front here, that's not standard form. On the right-hand side, maybe I didn't combine all the like terms, maybe I have a 3x over here, so that's not standard form yet. All right. So some of the homework questions, you may be given things in factored form. Okay, so like 2x minus 5 times x minus 3 equals 4. Well, how do you get that in standard form? Basically, you want to do all of the multiplication, okay, and then move everything over to the left to set it equal to 0, and then make sure all of the exponents go in descending order. So we have x squared first, next we have x to the first, and then just a constant, which is technically x to the 0th, so that comes last. So if I did this last example, and we'll end with this one. We start a new page. Okay, so to put this in standard form, I would multiply first, and you can use FOIL or you can distribute. Okay, so you're basically just going to multiply, like distributing is 2x times x, 2x times negative 3, and then negative 5 times x, and negative 5 times negative 3. And FOIL is multiplying the first terms, the outer terms, okay, and then inner, and then last. Okay, so it doesn't really matter what you do, but basically you're going to end up, you'll have 2x squared minus 5x minus 6x plus 15, and you might have a slightly different order, and that's fine. Alright, then combine like terms, so negative 5x and negative 6x. And then last, I want to move this 4 over. So 2x squared minus 11x plus 11 equals 0. Alright, and just to double check, the exponents do decrease, so that looks good. Okay, those are the things I just wanted to mention to get you started on the homework, and I do plan to thoroughly teach this chapter in class with you, but I wanted you to at least get a feel for the chapter, read through the bulk of it except for the examples at the end, and start to review or practice some of this information. Go ahead and use the updates page to post any questions that you have, and I will try to check in and answer those.